Here is my 2019 Venge Di2 dream bike from Specialised. I've customised this bike. I added a few things for my own comfort, like the handlebar tape extended over the handlebars, my GPS mount, a bell, a mirror, XC12 pedals, a security device, and something to put the spares in. The saddle is one of my favourite charged spoon, which I've got in all my bikes. Hello, my name is Alistair. I live in Scotland. The Specialised Venge became my dream. After reading all the promotional literature, watching the marketing videos, I also encountered an owner of a Venge and was willing to talk to me about the bike in the summer of 2019 when I was cycling the North Coast 500. I have now purchased a 2019 Venge Di2. It's not the top of the range and S-Works, but it's within my budget. The initial experience was very good with the bike. Certainly the first 300 miles. I really did enjoy riding it. It's fast, it's quiet, it's lightweight and good looking bike, admired by many. However, the bottom bracket after about 300 miles started developing a click. Now this is not unusual in the biking world, but I'm going to tell you my experience and see if you find that interesting. The noise is in the form of a click that develops every time you cycle the crank, and it gets louder and louder until the point where you have to change the bearings. I try and record the sound from this bottom bracket that's giving me all my troubles and doesn't appear until I've ridden about 10 miles. I have to switch to the other lens. It's been back and forward to a local bike shop dealer, but despite his best efforts, he's been unable to cure the problem. It's had 3 sets of bearings and 2 bearing adapters in 2,000 miles. Of course, I have viewed the Hambini videos and emailed him directly, and we have both concluded that my frame must be out of tolerance. The likely cause of my problem is a parallel error in the hole location for the bottom bracket bearings. Hambini says my frame may require a concentric one-piece bearing adapter that he is particularly expert at designing and manufacturing. I have 4 choices facing me. Open up a complaint with Specialised via the local bike shop, who are willing to do this, I may add. This, I fear, is a long, difficult road in the COVID environment and likely to involve me in legal threats, etc., asserting who is responsible for what and probable delays to my Venge experience. 2. Send it off to Hambini with an uncertain cost likely to be in the region of £300. 3. Try and progress the problem further. I'm an enthusiastic engineer with a workshop with lots of tools and knowledge, including a lathe and milling machine. 4. Live with the problem, changing the bearings every 300 miles. You can imagine how I feel about that. My theory about the problem is that the life of the bearing is almost certainly dependent on the tolerance of the hole in the frame, which has got an aluminium sleeve at manufacture. The tolerances can result in a parallel error which is particularly destructive to bearing life. If you don't believe me, have a look at all the Hambini videos on the subject. And in my case, this results in a click that develops over 300 miles. Specialised now employ a bearing adapter, a Praxis adapter, into the frame as supplied to me by the bike shop. This bearing adapter is a two-piece device, however it merely transfers the poor tolerances from the frame at manufacture into the bearings, as it has flex due to a threaded joint. I purchased a new adapter from eBay manufacturing by Wheels Manufacturing called a BB30 out. It's the same one that the bike shop fitted at the latter point to try and cure this problem. I purchased this new BB30 out adapter to try and understand what is going on and possibly modify the BB30 adapter to try and either better understand the problem or to cure the problem with my own resources. I don't know if you can see this very clearly, but here is the Wheels Manufacturing BB30 out, and the first thing you notice about it is that you can pull this thing, and if you measure that change in length, it's 0.3 millimeters. And if you can also rotate one half relative to the other by 0.3 of a millimeter. So it means that these adapters, rather than cure the problem with the tolerance in the frame, merely transfer the tolerances from the frame to the bearing. Another thing I discovered about this BB30 out, and particularly attracts me to it, is that if you make a sleeve, like I have done, you can fit that inside the BB30 out, and it will have a gap between it and the adapter. This diameter here is the same as the Shimano crank, and it rotates the inner part of the bearing if you press it, and if you screw the two halves together, it locks the bearings together. Now, if you have a parallel error in your bearing, for example in my case, what it will do is if you tighten that up sufficiently when it's in the frame, it will align the two bearings according to the error in the frame, so that the two bearings remain parallel regardless of what the frame is doing. You can also tighten the preload adjustment on the crank up as hard as you like, and that will also force this bearing into a slightly different position than it would normally naturally take up. I think you have to realize here that the tolerances we're talking about between one half of this frame and the other half of the frame, we're talking about anything up to 0.3 of a millimeter that this could be out before it impacts the BB30 out adapter, and that only results in 0.1 of a millimeter shift in this bearing tilt. I hope you can see this, but this is my drawing of the actual beastie here. The top is an illustration of this thing here, the BB30 out. The bottom part is the bearings separated out of the adapter with the crankshaft going through the middle of the two bearings. And I've magnified this error here. This is 10 times what it actually is, but the numbers are the real numbers. I can cope with up to 0.3 of a millimeter, which results in a 0.12 millimeter tilt in the bearing, which I think is reasonable for the press fit location. And here is the proposed sleeve, and you can see the sleeve is at this angle here. It's actually 2 degrees, but it's actually representing 0.2 of a degree. This is a real 3D drawing, by the way, and if I go into render mode, you can see that if I rotate this, the whole thing is a three-dimensional drawing. And we can return things to normal by doing that. I did this so I can illustrate the effect of forcing the two bearings into alignment. So what in sum total have we learned from this exercise? That there's more than one way of correcting such a parallel error. The Hambini route is by far the best, and it's much more sophisticated than my method. My method appears to work on my application. I can't guarantee that if you try it, it will work with yours, but it appears to work with mine. It's done well over 500 miles, heading for the 1,000 miles, and I've never actually had that amount of distance out of a bottom bracket bearing. What is the future of this method? Well, it's really up to whoever wants to try and replicate it. I'll give them whatever details are necessary to manufacture such a thing. It can be made in any sort of machine shop of any reasonable competence, and I hope there's other applications for it other than my own bikes.